Alright friends, welcome back. In this video I'd like to go ahead and begin section 3.3 of your textbook, and in this video we're going to specifically be talking about how you can divide polynomials in two ways. So first of all by long division, and then by synthetic division in certain special cases. So let's get into that, right? So say we want to go ahead and divide these two polynomials right here. So I've got x squared plus 2x minus 7, and then I've got this separate polynomial x minus 2. If I want to divide the two, which you can see there that it's basically written as a fraction. Anytime you see a fraction, that fraction bar is basically just division. We can go ahead and say that the numerator and the denominator there, we can go ahead and give those some names more according to the actual division problem. So you may remember this from back in elementary school, but whenever you do a long division problem, you have the dividend. That's the quantity that you are dividing, and then you have the divisor. That's the quantity that you're dividing by, okay? And so I'm going to be throwing those terms around in the video, so just make sure that you are familiar with those, right? Whenever we're doing long division, of course, we're going to draw that long division symbol. The divisor is what goes outside the long division symbol, and the dividend is what goes inside the long division symbol. And the only other note that I want to make here is that we just need to make very special care in making sure that these polynomials are written in standard form. So you remember that from a previous video. That just means that when you look at all the terms with x in it, all those terms are written with descending exponents on x, okay? We definitely need to make sure that that is something that you take care of before you move forward with your long division, okay? So what I've got here for you here in the notes is just basically a little bit of a step-by-step for how to go through and perform a long division. The good news is that long division is what we call an iterative process, meaning that we do something and then we just do it over and over again until we run out of stuff to work with, okay? And so we're going to see that here as we go ahead and do this long division problem right now. So the first step, it says, is to divide the first term of the numerator. Keep in mind that would be the dividend. We want to divide that by the first term of the denominator, and keep in mind that that would be, of course, the divisor, okay? And then put that in the answer, right? So, again, if I come over here, if I'm doing this long division problem, one of the things that I want to do here is, according to the first step, just take the first term of both of these guys and then divide the two. So, if I think about x squared divided by x, you got to remember how your exponent properties works. That would just simply leave us with x, which I'll go ahead and put up there in my answer, okay? Now, that'll take care of the first step. Coming back over here to the next step, it says multiply the denominator, remember that's the divisor, by the answer, and then put that below the numerator, okay? So we're going to go ahead and take this answer that we got, this x, and we're going to multiply it times this divisor out here. And when we do, just remember that that requires distributive property. So we're going to go ahead and distribute x to both terms. So x times x, of course, is going to give us x squared, and then x times negative 2 is negative 2x. Okay, and so that takes care of the second step, and you notice that I wrote it below the divisor, or sorry, not the divisor, I wrote it below the dividend so that everything is nice and lined up for me, ready to go. And now step 3, we're just simply going to go through and subtract to create a new polynomial, okay? And so we're just going to go ahead and take our two polynomials here and subtract the two, and we're going to find the following, right? So again, basically steps 1 and 2 are done on purpose, specifically so that when you move on to subtraction, the first column of terms here is going to cancel out for you. X squared minus x squared would simply make 0, and that falls out of the problem. But that next column is going to have to be something that you be a little bit careful about, because as I've noticed students over the years, when they're doing a long division problem, they typically make the most mistakes at this step right here, and it's because they're not being careful about the signs of their numbers, right? So just paying particularly close attention to what we have here in this column, I've got a positive 2, and then I'm subtracting away a negative 2. Okay, so if I take positive 2 minus negative 2, you recall from an earlier algebra class that subtracting a negative changes the operation to addition, so that would be 2 plus 2, or in other words, that would be 4x, okay? And so there we go. So that's step 3, and then moving on to step 4 here, it says repeat steps 1 through 3 above for each term, okay? And so we'll go ahead and do that here now. Okay, we are going to go ahead and drop down our next term here. So we have negative 7 that we're going to go ahead and drop down and call this new line 4x minus 7. And then we're going to take a look at those first terms again. I've got 4x and I've got x. And so if I just think about what I would need to go ahead and multiply by, or if I just simply divide the two like the guideline said to do, that would just simply be 4. So I'll say plus 4 here, and then I need to distribute that plus 4 again to both terms of my dividend here and write the result down below. okay? So 4 times x, of course, is 4x. 4 times negative 2, of course, is negative 8. And then we would go ahead and, of course, subtract here, okay? Again, done on purpose so that these would cancel out for us. 4x minus 4x makes 0. And again, just watching the signs of what we're about to simplify here. So this is going to be a negative 7 minus negative 8. Minus negative changes to a plus, so that's negative 7 plus 8, and that'll give us, of course, a positive 1, okay? Now, you'll see up here that there's no more other terms to go ahead and drop down here, so that means that we are all finished with that iterative process. We can't continue to reiterate the same thing over and over again because we don't have any more terms to work with. And so at this point, we're going to go ahead and skip on over to example 5, which is going to say how we're going to write our final answer, okay? And so in all cases, we're always going to write our final answer as quotient plus remainder over divisor, which may be something you remember from an earlier algebra class. So just kind of speaking clearly here about what it is you're looking at, right? This answer up here is actually your quotient, okay? So remember that a quotient is an answer you get after doing a division problem, and this is no different. So x plus 4 would be our quotient, and then this number down here is actually our remainder, okay? So the number that we are left over with after doing that iterative process, this is, of course, called the remainder that you get after doing that problem. I think OneNote is about to crash on me here, so we'll wait for that to crash, and then we will reopen it. Goody goody. So let's go ahead and open that again. All right. So that's the remainder, okay? And then over here in step 5, the way we're going to write our final answer is quotient plus remainder over divisor. Always, 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 okay? So our quotient here in this problem was simply x plus 4, and then we're going to say plus the remainder, which we found to be 1, over the divisor, which again was the denominator from before. That was simply our x minus 2. That will complete the problem, okay? So whenever you're doing long division of polynomials, again, making sure that we just simply follow this step-by-step process over here, making sure that everything is nice and lined up, and that we're taking our time, right? Because we're doing so much of the same work over and over again in that iterative process, you know, it might give you the potential to make a mistake or two as you go through. So just kind of be careful, okay? So let's try that one more time here. So example 1, it says find the quotient using long division, and so this would be the way that a problem would typically be presented to you. So just to be clear on how you would set that up, remember that you've got your dividend right here. This is the thing being divided. And then you've got your divisor right here. This is what we are dividing by. And so we're going to put the divisor outside of the long division symbol, and we're going to put the dividend inside of the division symbol. And before I continue to write the rest of my dividend, I want to go ahead and pause here and make a quick note. If you look at your dividend real quick, you'll notice that it is in standard form, but we are missing one of the terms in the sequence of standard form, right? So right here, we are going from our x to the third term straight to the x to the first term. And in order for long division to work in the way we want it to, we are going to have to go ahead and introduce ourselves a little bit of a placeholder in that blank space. And so that placeholder, since we are missing an x squared term, we're just going to say 0x so that we don't change our original dividend. Okay, so that's what I'm going to go ahead and continue to write here is plus 0x plus 4x minus 1. And then we can go ahead and start using our long division process, right? So again, we're going to go ahead and compare the first terms of our dividend and our divisor. We're going to divide the two. That's going to be negative 3x to the third divided by x. That'll leave us over with negative 3x squared. And then we're going to distribute that to both terms of the divisor and write out the result underneath the dividend here. So that'll be negative 3x to the third. Remember, that is supposed to match that term because, again, that's on purpose. When we subtract here in a second, those are going to cancel. And then we have negative 3x squared times negative 1. That'll give us a positive 3x squared. So again, the number one mistake that I typically see people make on these problems is mistakes concerning the signs of the numbers, so just be careful, okay? So that first column, of course, is going to cancel, and then in that next column, we have 0 minus positive 3. That'll give us negative 3x squared, and then we're going to go ahead and drop down our next term here. So that'll be a plus 4x that we pick up with, and then we repeat that process one more time, right? So again, looking at the first terms of my new line and my divisor, I notice that if I divide the two, I'm going to end up with negative 3x. Okay, and so that is what I will distribute to both terms of my divisor there and end up with negative 3x squared plus 3x. And then now that I have a new line, a new polynomial, I'm going to go ahead and subtract the two and just keep repeating this process over and over again until I run out of terms. And so that first column there is going to cancel out, and then that x column I have 4x minus 3x. That's going to give us 1x, or just x. And then I'm going to go ahead and drop down my final term here. That's going to be a minus 1. Okay? So we'll say minus 1 there. And again, do the same thing. We're going to take a look at the first term here, first term there. We'll notice that they're the same, but we're still going to go ahead and divide them because we want to go ahead and keep doing this until we have run out of terms to drop down, right? So what we would get after dividing x by x would just simply be positive 1, so we'll say plus 1 up there in the answer, and then distribute that 1 to both terms of my divisor, and then write out the result here. And you can obviously see that when we do that and subtract, we are going to find that not only are this first column going to cancel out, but also that second column, and that just leaves us with a 0 with no other terms to drop down. Okay, so remember that this right here, this is your remainder in the problem. And up here, this is the quotient above the division symbol. And so when we write out our final answer, because the remainder actually happened to be 0, when we write out quotient plus remainder over divisor, since the remainder is 0, then that is going to mean that that whole fraction is 0, which means that it's not necessary to write. Okay, again, in order for our context to make sense here, what we're basically saying that is that these polynomials divided evenly, and there is no remainder here. So the quotient there, the answer for the problem, is going to be this polynomial right here. So negative 3x squared minus 3x plus 1. Here's another example of a long division problem. Again, we're going to have to make sure that our polynomials are written in standard form, and we're also going to have to make sure that we substitute in any placeholders that we might need for missing terms in the sequence. But you can see here how this shakes out. This is just basically going to be another example of a long division problem, and this is actually going to have a remainder of negative 9 when you're all said and done. And I just want to go ahead and take a few moments to describe how we're going to go ahead and write that answer, because again, we're going to go ahead and start that off by saying quotient plus remainder over divisor, but you notice that because your remainder is negative, when I add a negative number, remember that that operation always changes to a minus sign. So there in my answer, you'll see that I rewrote that as minus the remainder over the divisor, and that is something I would like you to be doing if that comes up for you. Okay, so really straightforward process. Again, once you have that process down, it's just a matter of reiterating the same steps over and over again until you run out of terms to work with. But you can see here that that is a pretty lengthy problem, right? So that is something that takes a long time. So mathematicians are always interested in fun little shortcuts that we can take to make a long problem not so long. And that's definitely something that applies with long division here. Okay, so this shortcut method that I want to go ahead and introduce you to now is only going to apply in a special case, but if it does apply, we are going to notice that it's going to save us a lot of time. So this is called synthetic division, and of course it's only going to apply in a special case, and I want to talk about that special case right now. So if you have this special case, then you have the green light to do synthetic division. Okay, so that case is right here. So basically what you're going to do is you're going to look at your divisor. You're going to look at the denominator and notice whether or not it is a degree 1 polynomial, and also if the leading coefficient is 1, okay? And so we want the degree to be 1, and we also want the leading coefficient to be 1. So in other words, if your divisor looks like this, if it looks like x and then some number, then that means you have the green light to do synthetic division, okay? So in that dot box, I could have anything from like a -1 to like a +3 or whatever, okay? So as long as you've got that special form, that's the number that you're dividing by, then you're going to be able to use synthetic division. So let's go ahead and demonstrate that process right now. So example 1, it just says find the quotient using synthetic division. First and foremost, just checking, we do have the green light because it does say x. That's a degree 1 and a leading coefficient of 1. So that checks out. So we are good to go with synthetic division. And let's go ahead and describe that process here, right? So the first thing that you're going to do is you're going to go ahead and look at that number sitting next to x in your divisor. And the first thing that we're going to do with that number is we're going to change the sign, okay? So if it's a -1 written down on the page, we're going to change that to a +1. And then we're going to go ahead and turn our attention over to the actual dividend, okay? Because what we now need to do is we need to go ahead and write out a complete list of all of the coefficients of your dividend and also the constant. Okay, and so if we take a look at those numbers here, that's going to be a +1 in front of x to the third, that's going to be a -1 in front of x squared, that's -2 in front of x, and that's +8 as your constant there. So we're going to go ahead and list those numbers out here. So there's 1, -1, -2, and +8. Okay. Now, in order for us to kind of remember which number was our number that came from the divisor and which ones came from the dividend, you typically see people putting a little bit of a separator in this work right here. I've seen everything from a circle to a box around your dividend number, but the way that I was taught when I was in high school, and one that I think you'll oftentimes find on online resources and in textbooks and everywhere, is just like a little corner symbol right there, just something to chunk that number away from the numbers for my dividend. Okay. And then the only other thing here as far as setup is concerned is I'm going to go ahead and write a little bit of a result line there, and then because later on we're going to have to add the numbers in the columns, I'm just going to go ahead and give myself a little reminder that that's going to have to be the operation. Okay. Now, as far as synthetic division is concerned, this would be the setup, but you do have to know how the numbers move around and how to perform the actual procedure here, okay? We're going to take a moment to talk about that, but again, if you get familiar with that process, though, synthetic division is meant to be a shortcut. It's meant to be one of those things that takes you not even 5 seconds to do, because all this is going to amount to is basically multiplying and then adding a bunch of numbers over and over again, okay? So it's another one of those iterative processes, but you're going to find that this is going to be a lot easier to do than long division. So let's actually get started with that, right? So the first thing that we're going to do is we're just going to simply drop the first number, okay? So we're going to drop the first number below the line, and then after we do that, we're going to go ahead and multiply numbers in a special way. We're going to take the number that came from our dividend, we're going to multiply it times the number down here, and then we're going to write the result in the next available space in the next column over. So for our purposes here, that's going to be a 1 times a 1, and then that's going to give us a positive 1 as the product, okay? So we're going to go ahead and write that number as the result there. And once we have a number in that column, we're basically just going to go ahead and add the numbers that are in that column together. So that would be simply a -1 plus 1, and that would, of course, make 0, okay? Now that you have a new number down there below the result line, we're going to go ahead and do that process again. We're going to go ahead and multiply the number on your divisor times this number down here, and the result is going to go in the next available space. So that's going to be a 1 times 0. For us, that's going to be a 0. And then we add the numbers in that column. So that's -2 plus 0. That's going to make -2, okay? And then we just keep going until, again, we run out of numbers. So that's going to be 1 times -2, and that's going to be the resulting new number in that blank space there. So 1 times -2 is, of course, going to be -2, and then we add the numbers in the column there. That would be 8 plus -2, and that is, of course, 6. Okay? And then after that, we run out of numbers, so that means that the procedure part of the problem is done, but now we need to pick up with the interpretation part of the problem, right? So we need to be able to do something with these numbers that are down below the line here. Okay, so what these numbers are, the very last number that you end up with in synthetic division, this is always going to turn out to be the remainder after the division. Okay, so it turns out here for us that that's just a matter of 6. Okay, now that kind of begs the question, what's the deal with these other numbers here? Well, these other numbers, these are the coefficient and the constant of your terms in your dividend, okay? And so what I like to do is I like to go ahead and start with the last number in the list. Here, that's -2, and then just kind of work backwards, right? So -2 would actually be the constant of your dividend, and then the terms that are the numbers that come before that constant, of course, are going to be the variable terms, and they're going to have that order in their exponents, right? So if I go to the term before the constant, that'll just simply be my x term, and if I go to the term before that, that would simply just be my x squared term, again, just kind of adding 1 to the exponent as I continue to go left. So I'm seeing here that my quotient is actually going to be the number. If I go ahead and simplify this down a little bit, I don't need that 0x in the middle, and I don't need that 1 in front of x squared. I'm just going to go ahead and write this as x squared minus 2, and that is going to be my quotient, okay? And we are going to go ahead and write our final result in the exact same way that we did for long division, where it was quotient plus remainder over divisor. So writing our final result here, we're going to have x squared minus 2, and then plus remainder over divisor. Okay, so again, we're going back to the very original problem and looking at the divisor that we first initially started with there. And so this would be our result right here. Okay, so dividing polynomials is going to be very, very easy with synthetic division if you notice that you have the green light to do so. Again, you do need to look for the divisor having a degree and a leading coefficient of just 1 to give you the green light to do this process. Okay, you notice that I did the next example there for us here as well. So again, I'll just kind of put that up here on the screen. Again, going through that whole iterative process, being able to interpret your final line of numbers there. Remember that this number is always going to be the remainder, the last one, and then again, remembering that trick that we talked about in long division before, where if it was plus remainder over divisor and the remainder is a negative number, we're just going to automatically change that operation to subtraction for us, okay? Here's another example right here. So there is the polynomial. This is going to be one that we need a placeholder for. So just like for long division, if we notice that we have a term missing in the standard form sequence, we're going to need to introduce a placeholder for that, which would basically just be 0. And you can see that is going to be the case there when I set up my synthetic division. And the other thing that I wanted to point out here is that sometimes when you do synthetic division, your numbers are going to get very, very big, as you see here in this example, right? We got as big up to a negative 511, right? And I think that that is the sort of thing that tends to tell students that they made a mistake somewhere, but it's just kind of the nature of what we're doing. Sometimes your numbers are going to be super, super huge, and that's okay, okay? So just make sure that you're setting it up correctly and that you're going through that process correctly, and you're always going to be able to get the right answer, all right? Now, one of the neater things that we're going to be able to do with synthetic division is we're actually going to be able to use it to evaluate expressions, right? So when you evaluate an expression, you're going to basically be taking the number that you're given, and when you evaluate it in the past, what you would be doing is taking this number that you were given, and you would be plugging it in everywhere that you saw an x. Okay, and that wouldn't be too hard for us to do because we have calculators, but you got to keep in mind that not everybody had calculators in the past, right? So they needed some shortcuts like this for being able to evaluate polynomial functions that would be relatively quick and easy to do without having a calculator that didn't exist back then. So this would be another way to evaluate a function at a variable or at a value, but by using synthetic division, okay? And so here's how that process works, right? Before, when we did synthetic division, we changed the sign of the number because the way the problem was presented to you was as a division problem. But here, it's not presented to you as a division problem. It's just presented to you as, here's a polynomial, here's a value that you need to plug in. So in this case, we're not going to change the sign of the number at all. We're just going to go ahead and stick with what the actual number is, and here that is going to be just simply -3, okay? So that is going to be our number for the synthetic division that quote-unquote comes from our divisor, and then we're just going to go ahead and simply list out all of the coefficients of my dividend here. So just to go ahead and highlight those really quickly here, that is going to be 5, -1, +13, and then +29. Okay, and then just again to prove to you that this is supposed to be a process that's supposed to go really quickly, again, let's just go through that really quickly, right? So I'm going to drop the 5, multiply my -3 times 5, and that is going to give me -15. Add the columns, so that's -1 plus -15, so that's going to be -16. Then we're going to go ahead and multiply here, so that'll be a negative times a negative, which makes a positive, and 3 times 16, of course, is going to give us 48, so we'll say 48 there. Add the columns, 13 plus 48, that's going to give us 61. And then we are going to go ahead and do that final multiplication there. So -3 times 61, that is going to be a negative times a positive, which is going to give us a negative number. And again, just be aware sometimes you guys are going to have some numbers that are relatively huge in the problem, but it doesn't mean you made a mistake. It just means you have a huge number, okay? And that's actually going to end up being 183, okay? And then we're going to go ahead and add the numbers in that column there. So that's going to be 29 plus -183. That's going to give you a -154 when you're all said and done. So interpreting our answer here, we would say that this is our remainder, whereas the other numbers in this line are the quotient. But now, again, we're doing something different. We're supposed to be evaluating the function. And here we're saying that you have a quotient with a remainder of -154. There's actually something in mathematics called the remainder theorem. And basically what it says is that this remainder is actually going to be what you would get as the output if you were to plug in this number right here as the input. Okay? So just to prove that to you, I'd like to go over to the calculator here really quickly and do something that we haven't done in a while, which is to use the store function of the calculator, okay? So we have a value of -3, and we're going to store that into x as a variable, right? And then we're just going to go ahead and type out our polynomial here. So anytime we do press that X button, it is going to be one of those things where the calculator is going to treat that X as the number that we stored in there. Again, just a little bit of review of things that we've done in the past here. So I'm just going to go ahead and type in the rest of my polynomial here. And again, every time I press that X button, it's going to treat it like a -3. And if I press enter, it does give me -154, which is exactly what our remainder is going to be here. So that is going to be the answer to our problem. So -154. And again, the reason that we are having you guys do this in the world of calculators is because, it's good practice over synthetic division, and it's also a pretty handy trick, okay? If you don't have access to a calculator immediately, this could be something that you do to really easily figure out what the output of that polynomial function is going to be given that input, okay? And so just as another example of that, we have the following example here, so same thing. I'm just going to borrow that value. I'm not going to change the sign at all because here they just handed you the value instead of handing you the divisor. And then we just go through the synthetic division process, and we end up with a remainder of 436, which I've gone ahead and shown the work down there. If you were to plug in 5 into this polynomial and figure out what the output would be with an input of 5, then that would be the same number. That would be 436. So this is the way that people would evaluate polynomials back in the day before the time of calculators. So that's going to do it for this video. Thank you very much for your attention. If you guys have any questions, as always, feel free to let me know. Just a little bit of long and synthetic division in this one. So that's all I have for this one. Thank you very much, and I will speak to you in the next one.